Very good.
Thank you very much. I'm really excited that you offer us this opportunity, and I think this is a great mix of people, and let's use this opportunity. Sadly, I will have to leave this afternoon already at 4 p.m., but maybe we can use the time until then. Yeah, okay. Yes, as Sönke already mentioned, I'm actually a librarian by training, with a little bit of background in social science. And please allow me 1 minute just to brag a little bit about. First, yeah, my agenda is I will try to look as concrete as possible into 4 use cases. Yes, and maybe if you are interested in one or the other, we can go further into this afternoon. Maybe let's just have a look. So I come really clearly from the research infrastructure side of things. We are a small team doing research and development in research infrastructure in this large library in Hannover. And so this is my background and my motivation. And I want to tell you a bit about these cases and why blockchain is a really promising solution for actually tackling problems that we have in this space. So, yes, let me do 1 minute of bragging about my institution. Maybe you never heard about TIB. TIB is the German National Library of Science and Technology and sits in Hannover. And we are very excited about this approach still, about linked open data. How many of you know this linked open data cloud? Okay, some hands at least. Okay. So our for those who already know this, you know that right at the center sits Wikipedia, and our library director, my boss Sören, is actually the inventor of this piece, of the centerpiece of the linked open data cloud, Wikipedia. One other typical thing about TIB is that we came up a few years ago with DataSite, which is a network of research data repositories. So we make sure that we have standards in order to make data actually citable. Yes, when you see these small DOI numbers and references of academic articles, have a closer look. It's actually since a few years now possible to really point using these unique identifiers to research data sets, and this this was for that time a really cool invention and still necessary. And maybe two other things we engage. For instance, together with Sasha and a few other people who sits right there in knowledge exchange, we do kind of an advisory thing for the European Commission about science policy, and we engage along with Sönke and others in the Science 2.0 Research Alliance of Leibniz and a lot of other stuff. So in the end, if you are into data science or an IT developer and want to come up with cool solutions in this space that we are talking about now, you can join us up with TIB and learn about the real world requirements of the information landscape. And yeah, okay, let's have a look into maybe just a very quick reminder the problems of centralized approaches in the academic information landscape. And sorry that I pick up on Elsevier. I could have taken an example.
No problem. Please go.
They're used to it.
I could easily.
I was 15-year scientist, and I know the other side as well. So please.
Great. Okay, so I could easily replace all the bad examples from Elsevier with examples from Springer Nature. This would be no problem at all. So don't mind. So maybe you heard about Elsevier acquiring BPress, or you heard before a few years ago about Elsevier acquiring Mendeley or SSRN. I don't know if you're familiar with that. So it shows that Elsevier and the other large publishers very well know that their current business model of selling access to artificially enclosed scholarly work is somehow limited, and they now begin to change their business model and become kind of a platform for science, yes, which is like a tool set of all kind of online services for doing science. And this is what they actually do. And you can say, okay, so if this is a valid business model, why not? If Elsevier runs an open access repository like SSRN or Pinterest, why not? But then again, look at this news from only a few weeks ago, where they came up with the idea of a proposal of a new concept of open access, which entails geo-blocking large parts of the world, yes, which is, by the way, in no way open access. But let's just try the waters, yes. What happens if we make this idea? And yeah, so this is really kind of frightening and a problem, because science now largely relies on many platforms that are governed by all kinds of business models, different concepts of what open science and open access actually entails, different kinds of APIs, often unreliable, and so on and so on. So if you want to go a little bit further into that, there's a little interview with me from last year in the London School of Economics blog, LSE blog, about the need for maybe a kind of open operation system of science. So pretty much what Elsevier is doing, but in a more open way. Maybe. Okay, so let's dive further into the concrete use cases. Who knows this life cycle, this research object life cycle? Have you ever seen this? A few hands go up. This is really interesting. If we have time this afternoon, we could further look into this, because this is neat. You have these life cycles of a research object, or what researchers are actually doing, and then a number of services that we have now that are working in this area. So these were two librarians from the Utrecht University Library, Jeroen Boosman and Bianca Kramer, that came up with this idea. They did a large survey, really interesting, where they actually found out about what services are actually used by scientists. So for now I want to really focus on only 4 small use cases to take not too much time here. One case is text mining across lots of scholarly articles. We actually have right now a Deutsche Forschungsgemeinschaft funded project in my group, where we do text mining across like millions of articles. And really, believe me, this is not so unusual. You find these kind of things in lots of areas of science. Just to give a few examples, you have in medicine and other areas meta-studies, where you look into the data of a lot of other studies and then make your statements about what you find out by comparing them or putting the data together. Or think about the digital humanities, yes, who have all these kind of distant reading technologies, where it's about finding patterns in large chunks of the literature, and so on and so on. So this is really not an unusual use case. And in order to get your hands on lots of papers today, you have to go, as I said, to a lot of platforms, yes. And the important thing here is you have to go through their owners and their kind of business models, yes. And you, more concrete, you have to go through different APIs. So there is, for instance, a standard called OAI PMH, which is kind of an API for going into open access paper repositories. But in the real world, this is highly unreliable. It does not fit to get large chunks of paper in a reliable and really standardized way, because everybody has its own interpretation. Often, if it's limited, how many papers you actually get through this, and so on and so on. And let's keep aside for a moment file formats. That would be another weekend maybe, which is maybe another topic. But this is another issue when you actually do text mining, because there's a lack of standard as well. So what is a new perspective when we know about blockchain and peer-to-peer data networks especially? You have this idea of having a shared data space, yes, where you address objects not through their URL with a physical place, the server where it sits, but instead addressing them by their content, yes, using their hash name. And so this concept allows everybody to literally own lots of shared objects, and at the same time, if they want to reshare them, and thereby helping the scholarly community to keep them up and to keep them online. And there are already proven concepts for that. Mostly, I think about DAT and IPFS. So you may know about this. I won't go into the technical details here. But there will be an opportunity to learn more about that this weekend, I'm sure. And there are even more ambitious ideas about that, like for instance MaidSafe or the IPDB people. So this is a joint movement from joint idea from IPFS and the big chain DB people here from Berlin. And this is about kind of an advanced. It's more like it's more than a peer-to-peer network. It's really a decentralized app that rewards you for giving your spare storage space or your CPU time or bandwidth to the network as a whole. And this is quite interesting because this is kind of a self-governing, really autonomous kind of network. And actually I had a really interesting little debate about this with David Rosenthal. Who knows about locks and clocks in this room? Did you already get about? No, this is maybe some very special thing from the research infrastructure community. These are solutions made for redundant availability of open access journal content and paid journal content as well, where you have a network of libraries that share their resources. And so David Rosenthal is kind of famous in that area, and but he thinks I'm kind of mad and fall prey to a blockchain hype or so. And this is but this is quite funny. Read it. And okay. These are mostly applications that are currently only in alpha, but we can learn about their concept, what they try to do, and I think this is actually worthwhile. And let me know. Yeah.
Should I ask a question?
Yeah.
You were saying that the problem with different databases and APIs, but surely all these different methods of distributed storage also have problems sharing data between them or transferring data between them. Would you not say so? Or there will be some sort of APIs and gateways to crash to be able to share data between different blockchains. What are your thoughts on that?
This is the case already, yes. We have this kind of problem. For instance, Mike and me and other people here in the room were until yesterday at the Force 11 conference here in Berlin, which is from the scholarly communications community, or open scholarly communications community, so to say. And you have several initiatives, like for instance, manuscript sharing thing, yes, which is all about this problem that researchers have, that they often want to submit their manuscripts to a number of journals, actually, yes. And there is always this kind of problem, or you have this kind of problem of interoperability between open access or preprint repositories and journals, and so on and so on. And there are endless of approaches, but still the basic concept, which is applied nearly everywhere, is the idea of publishers somehow administrating their content on their platform. There is maybe one little real step that was done in this area, and this is Zenodo, famous, very interesting preprint repository with CERN in Switzerland. They allow researchers to add manuscript to the repository from their Dropbox at least. This is a little baby step, yes. But still the idea is then still that they just take it from Dropbox and have their own copy and their well-guarded Zenodo thing, yes. So it's not really like adding resources or taking part in a peer-to-peer data space. Sorry, I think this wasn't really the answer to your question.
I was really asking more about how a peer-to-peer network solves the problem of different APIs, different apps, different ways to access and share data. And say, for example, can you share data between IPFS and that? And what's
very interesting.
I mean, you have to probably design different ways to dive into each one of them. And then as they grow, and we all can split into different P2P networks, you will possibly get the same problem as you were pointing out is with the centralized databases.
Very good point, very good point. I actually tend to think that we will someday it will turn out that certain peer-to-peer networking standards will maybe take a lot of market share, yes, but still we will have different approaches, and we will have this issue of then again of having somewhat maybe larger shared platforms, but they will be platforms in a way. So yes, interesting point. And there's no easy solution to that, of course. Yes, you can think of nodes within your peer-to-peer network that somehow cleverly mirror content from both or more networks, more than one network, to each other. This is maybe possible, but this, yes, would require extra effort and maybe fits not so well into this rewarding structure again. So yeah, let's discuss about this further later. So, sure.
I was wondering where you find these use cases. Is there any literature on this topic? I mean, some people I mean, or you just created these use cases in your head about how we can apply blockchain for open science. I just want to hear about it more, and I don't know where to go. Yes.
This is just theory. Nothing of that is real. There is no. The closest thing to what I told you now is Zenodo with this Dropbox thing. But there is no. I don't know of any real journal publisher or repository. We do this kind of stuff at TIB, and we are not there yet that we really apply this kind of thing. But I think around next year we will maybe start a pilot in this area. This is not so far-fetched, because the real infrastructure on the side of peer-to-peer networks is already there. Yes, you can try it on your own local machine and it's working.
Okay, thank you.
Sorry. This is just memory here. Yeah.
I think it would be fair to say, in the scholarly ecosystem, I don't think that the use cases are well written. Like we have people saying all kinds of things, but we don't have a canonical source of use cases where we say that is the, if you could do these things, that would be the scholarly ecosystem. We don't have that, I think, right? So yeah, but I think some principles are emerging that people want to abide by. and those principles involve access and sharing and being able to attribute work. So when you talk, so your first use case about being able to mine papers is responsive to that. It is an example of the principle of access that you are supposed to be able to do that, okay, without technical barriers. Okay, so we're supposed to be creating an ecosystem in which those technical barriers do not exist. Okay, so that's what we would head for. And in that system, where those technical barriers don't exist to mining papers, we would be able to attribute work, okay? And we would be able to certify work. So peer review is another fundamental idea in the scholarly ecosystem. Okay?
Great point.
So while I don't have a complete set, I know that some of these things seem fundamental. Okay, and building the scholarly ecosystem without those things is wrong in some way. It does not serve scholarship, and so walling things off or creating separate things. None of that is in service to scholarship, and so we're trying to conceive of a way to provide the knowledge of the world in some open and accessible and attributable and certifiable way. And there may be some other adjectives I was supposed to put on there, but that's I think that's what we're thinking about.
Absolutely.
Yeah.
Sorry. Yeah.
So I'm not sure if that fits now, but maybe you were aiming for this, but I think the problem is the scholarly writing or whatever you define it as itself.
We're absolutely fine.
So because what you're trying to solve now here is to make to provide access to these different sources, okay, technically, but secondly you have this human interpretation and that spin in the paper maybe, and then I know that the big companies are working on, like Elsevier, they show off these pathway analysis tools for biology now, for instance, and I look at it and say, oh, that's nice, but I wouldn't even want to pay for it because I know that the data have been mined by human biologists, expert annotators or whatever, but the fundamental basis was already wrong. So, so the idea would be to, you need definitely someone that's writing about the science and communicating it. But maybe that can be really the job of these journals, but they pick on the stuff that is there and have the scientists just do their science. So meaning that the only entity that you need as a distributed network would be the data, the code, and a little bit of interpretation in a way that it's interoperable.
It's a wonderful statement. I absolutely subscribe to that.
I mean, I'm just saying because what you're trying to solve now is how to, of course, bring in all the knowledge that has been generated up to now. But is it really worthwhile to keep going with this terrible way of writing? Took me a long time to get it. Now I can write my papers, right?
So he wants to text mine papers. But we want to aggregate data.
Yeah.
We want to aggregate data. It's the same thing. We're supposed to be able to put our data out. So and reuse it and combine it, and we shouldn't have barriers. And the barrier could be that it's in your database. That's a barrier, okay? Or that your lawyer has attached some usage rights to it. That's a barrier.
But I think the access layer right now is through the stuff that was written for a human to read it. And obviously, I don't want to go into that AI and blah, 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 it's so cool. No, but I think just that's an interpretation layer for the human that. If we find standards on the underlying thing.
I was just about to name a few very concrete examples, and I think text mining still in the next few years will have its role because we have this large chunk of literature there, but otherwise I completely subscribe to your point. It's all about, and it will more than ever will be about sharing raw data from the get-go as soon as the sensor detects something, to share it with the world openly and reliably, and to share code and methods and everything. Sure. And it's just a matter of focusing here on a few really certain use cases that we very well known now. Yes. Yeah.
Just something to add to that, because I'm working on these programs. You just mentioned the text mining of science directly, and when you look at that, that's exactly as you said. We are reading the opinion of an author that you may disagree, and you see the data. So I interpret the data completely different. So what I think we need to learn from a technology point of view is to interpret a picture. There's so much data. I work in life science. Most of my data is pictures. Well, I don't care what the person is interpreting in there. I want to analyze purely the data. And what we are trying to do is not only do the data mining on what is written, as you said, that's still available. I think what we need to do is, and from all sides, scientific community, figuring out how we get the data in structure and distribute them that is basically unbiased. That is something that we need to develop. And there are not many people in this system who are doing that. That's why I'm glad that we can do this kind of discussion here. So what we're doing, for example, we are having a unified data model which is open access. So we donated that to the Pistoria Alliance. It's the largest open pharma group basically. So that enables scientists to put their data in a format that you can then share and put together, and you can analyze it at a large scale in the end. So you don't have to read the paper basically. It's only a certificate for the data you're going to publish. So that could be an interesting thing for as a proof of work, that you publish data, you propose them, and through a peer review process, you not only confirm the paper, but you confirm the data which you have in structured form. That you distribute.
I come exactly to this question in a minute, so thank you. Great. Any more questions at the moment? Otherwise, we can discuss all of this later. Of course. Okay. Let's take another very simple and very basic use case, and this is attribution tracking. Yes, we have right now this situation where some statements about the scholarly object, for instance, who contributed actually, and in what area, and how much, and so on, can be stated in a very neat way. We have a taxonomy for this, a cost-by-credit taxonomy. And today it works like you have a corresponding author, you have from the journal publisher, an editor, and so on, and all this data is collected. And essentially, the incentive infrastructure in this little use case here is completely broken. Yes, because publishers are not really interested in finding out exactly who contributed what. The people who actually care about that are those who contributed. But you have this corresponding author giving some bulk information about some object, and then the journal editor don't care to make it better. So this is really kind of a problem. And think about it. You can make your statements about what you actually contributed to some object on a blockchain. Why not? And if you work on a modern version management system like Git, better, you don't have to actually make that statement, but the software is making that statement in the background. Yes, but this is often not the case for science today. So let's take the old model. Yes, say you work on your manuscript on Word, share it via email, I don't know. And still, you can directly hack it into the blockchain. And in this way, you fix this broken incentive structure. Yes. The folks that are actually involved in the process make the statement, not the other way around. And this, by the way, would level the playing field of service innovation as well. Because you would then have a single source of truth regarding the scholarly metadata, yes? You have, in a way, a publicly owned API, or a publicly, even better, a publicly owned dump of all the data, yes? And you can, let's take that concept of a lens again, yes, from this great keynote that we just heard, yes? This is really something worthwhile because you can have lots of different lenses on the same thing and establish all kinds of new services, businesses around this. And the exciting and really interesting thing here is that this is a piece of critical infrastructure that Mike pointed out. We had to, he initiated a blockchain session at the FOSS 2017 event. And this is really a critical piece of the infrastructure because all kinds of research assessment that decides about young researchers' career build upon it. So peer-reviewed or not, this is really important. And we should not let this happen, that this kind of information resides on different publishers' platforms. Why? This is kind of small metadata pieces that very well fit into a blockchain. There's no problem with that. We can do that right now. We can start this weekend to do such a thing. And this would actually change a lot. And then you have advanced ideas expanding on that. Like for instance, Media Chain, I don't know if you know them. This is very interesting. They were recently acquired by Spotify. And what they do is they have some artificial intelligence in the background. They index all objects and they find out about original patterns in visual work and put these patterns on a blockchain, so they are kind of time-stamped. And when someone else comes up with a reproduction or a remix, which is completely nice and good to have, this person does not have to actually credit the source, but this artificial intelligence finds out about this in the background and lets users, viewers of this new remixed work know about this, the original source. So this is the future of giving credit. Why do we have this to do this manually? I mean, we can easily track where ideas come from. There are patterns in every kind of research result, in every visualization, let alone in the raw data. This is very easy because this is really lots of very highly noisy data, so you can easily find the patterns therein. And there's this German startup which got a grant from Google News Initiatives. They do this with textual material. They use this, I don't know the name of the blockchain again, but they do this with text. So let's move on. I will try to give you a concrete little user story because I learned from the usability engineer within TID that you have to give user stories. So let's say I just spotted I wasn't attributed right in my research group's last paper. So what I would do today mostly is nothing, because there's essentially no workflow for this. Yes, if I really would set up an email to the editor of that journal or to the people who run that repository, they would be like, hello, somebody there. And this could be so easy. You just take up your smartphone, you have your wallet app, you are connected to a peer-to-peer network where it's absolutely sure that this directly comes from you, and you update this kind of information. Yes. You add the missing attribution. And downstream you have all kinds of services like, for instance, Vivo scholarly profiles or a splash page for that article on the World Wide Web, whatever, and they can fetch the most recently updated metadata and therefore your attribution when displaying this object and so on. This could be very easy.
A question?
Yeah.
Sure. I don't understand how the network knows that you actually contributed to the paper.
Nobody knows. This is just a statement. And this is all fine, because this is just what you do right now. I mean, you put your name on the head of some Word document and claim that you are the author.
Okay.
And then it turns out that if you are Theodor zu Gutenberg, that you maybe are not really the author. And the old kind of systems give you the opportunity to maybe change your attribution without anybody noticing. With this kind of thing, everybody will know that, because you have a revision history of every attribution claim that you made in the past. So this is the only real change.
10,000 people make
somebody publishes a high impact piece of research, 10,000 people, 1 million people make claim to it.
Sorry, yeah, sure.
How does that solve any problems?
This is not really a problem because
Well,
at
the attribution is a problem that you presented us for the last 10, 15 minutes.
Sorry. Yeah. Okay, let's go a little bit more into detail here. If you submit your object into a peer-to-peer data space, you address it by the content using its hash name. So you actually know this name before you make it available to the rest of the world. So you have this original data, or you have this visualization, or you have this interpretational text, whatever, and you know you are the only person in the world, or you are a research group, whatever, who knows it by its name because it's not yet published. And then you make your statement before everybody else.
So you need some crypto security layered on top of this to be able to actually do it. It's not as simple as just making your links.
This is all, you can imagine this is all within the smartphone, so-called wallet app, where you have the cryptography needed in a neat app, and we already have this. You have this as a browser extension, you have this as a smartphone app, whatever. This can be actually done. I spare you the technical details, but you are right, there's more to it, what I just say, yes. I just point to what is actually possible today. Yes, we can go into the details later. This is a great point. This is not so easy. You need lots of cryptography to make this actually work, right? So, for instance, you need to make sure that if you accidentally lose that nice phone, what happens like every day, then you still can make this kind of statement. So you have to make sure that your private key is not only on this device and so on. So there's a lot of details to think about. So let's go very quick again to peer review. This was already mentioned, and this is maybe my last use case, I hope so. Again, very quick and very superficial, without much detail. You can easily think about smart contracts and zero knowledge proofs in addition that help you, for instance, to first determine who could be the right reviewer for your piece. So, and the interesting thing about this that there's no need, again, this is a disintermediation of the actual journal editor. Why should anybody do this? You can do this in an automated manner, given you have enough of the critical data on chain. This is the point in fact, yes. You don't do it out of thin air. Today you have all this crucial information about potential reviewers in proprietary databases that is shared among large publishers. And this is kind of a crucial part of their business model today. We can change this. And to give you one very concrete starting point where this already begins to change, look at the Netherlands, look at MIT Media Labs, look at Open University in UK, and there soon will be another company in Germany that is doing it. They do educational certificates based on a blockchain. So you have essentially already a few data sets of asserting people who own this kind of information with their wallet apps that assert that they have this and that qualification, academic qualification. So this is already starting in a way. So let me just end the slides and then I will take questions, yes. And another example for what a blockchain-based peer review would actually be good for is blindness. Yes, you already know about that, and from a certain perspective, it can be meaningful to have blindness in a peer review process. Let's say, for instance, you are part of a minority, yes, and you won't give that detail about you away. Maybe later, but not yet. When you are peer reviewed, and you can do that easily with zero knowledge proofs. So you can, and this is the elegant thing about this kind of proof, you can actually prove that you are the author of this manuscript. without at the same time giving away any more detail about you. And this is the interesting part here. And we have the starting points already. And again, this is about disintermediation. And this makes this kind of business processes far more efficient and far much faster. Think about nano publications, yes. We have also with Elsevier and Nature Springer already this concept of micro publications that are only about one statement that I add to the body of knowledge that we already have. Like in one RDF triple, yes, stating something that I found new about a particular molecule. Okay, I personally couldn't find out something about any molecule, so that's that example, but you understand what I'm talking about. So, going through the attribution process that we now have for scholarly articles with those nano publications would be really ridiculous. It wouldn't work. The economy of this would not work. So we have to come up with a much faster, more efficient way. And this is pulling all of the review attribution process, the whole of this research object lifecycle to the blockchain. I guess this is more or less evident. Yes, we will have to do that. In the best interest of how the scholarly information cycle works. And now, I have finished my case here with the use cases, and now some last slides, two last slides. Pretty please do not let us reproduce the reputation game of science. Yes. I give you here, who in this room knows ResearchGate? Nearly all. Who has a ResearchGate profile? So, yeah, many of you. And so you certainly will know this completely garbage, meaningless ResearchGate score. Yes. Which is just a measurement of what you do on their platform to their terms. So, and people actually care about this because this is kind of a gamification thing which works, yes, and which helps them to engage millions of researchers on their platform. And I would pledge to just not do this again, over and over. Because we actually do not need more artificial competition in science, yes. We have enough of that, and we don't need any more popularity votes. So just to make sure that you understand what I want to say, I like actually the idea of researchers assessing each other's work. This is essential, yes. We in some way we need to do this, but this should be not about a person, but a person's work and actual research outcome. But then again, I don't want to pick on ResearchGate. I actually like them pretty much because they came up with some things that are really great. So they have this really huge social graph of people who are actually connecting with each other and use this platform to collaborate and so on. And they have this timeline pattern where you can really have the opportunity to learn about what happens around you in your social environment of researchers who are up to something in your area. And I think, again, we already have the building blocks of we just learn change is easy. Yes, I even don't have to prove it. You know it already. Change is easy, and we have the building blocks ready. In this case, I would say Akasha World, which is a social networking system only based on Ethereum and IPFS, is already the main building block that we need to disintermediate platforms like ResearchGate. There's not much more to do. In the next version, they will come up with a kind of plugin system, so they know that it's interesting to enhance on what they do, and we will have to have an additional layer for pointing to objects of scholarly interest and things like that. So my very last slide here is, what will research look like? I think we can already learn from history that with new technical opportunities come new norms and new standards. That's pretty easy. And today we have things like fair data, that is findable, accessible, interoperable and reproducible research data, which is great. Yes, we should strive for this ultimate goal. This is great. We have lots of open source software in science, which is great as well. And I promise you, it will turn out that we have even another level of openness or an additional layer of openness by demanding that the whole critical infrastructure of science is to be completely open and publicly owned. This will happen because the technology building blocks are already there, and it's kind of inevitable that this will be the expectations against science. Because as you now demand that when you see a scholarly article, you can absolutely quickly look up the raw data behind it, yes? You will demand that you know about the research data as soon as it is there, actually, and have it assessed in a completely open and completely predictable way, governed by smart contracts and so on, because it is essentially possible already. So we will end up with science being some kind of a glass factory. Yes. And this is interesting. And I guess we will learn to change our behavior. This will maybe also hurt, yes, because some of the confidence that we have by keeping on our own within our lab, yes, and not letting instantly everybody know what is going on is kind of comfortable and convenient as well. And we will lose some of it.
This is the business model of most biomedical labs at the moment, and I really hate it. I mean, I'm proud of it, but I think it's terrible.
And it's terrible and it's convenient all at the same time. Yes. So this hurts. This is kind of the overlaying cultural change that we must achieve, that we try to achieve. Yes. And yes, I'm really looking forward to the rest of the weekend. And here you can see a little bit more about my ways of thinking about blockchain. And thanks again to Wimke.
Well, I don't think you are crazy, you are just ahead of the things. Okay, are there any questions?
Questions, maybe.
Yeah.
Follow me on Twitter. We can keep in contact after this event.
So thanks a lot. It was very interesting. You mentioned on one of the slides, let's not repeat the reputation game, giving the example from Sochi, etc., and let's not focus on competition so much. I'm just wondering, do you envision a future where there's literally no competition among scientists, and that all work happily together like in an open source community? Or does competition shift to another area, and which area would it be?
No, actually, I think there will be still lots of competition. I mean, until we really come to that, and I guess Wimke can say a little bit about that because he has this grand vision of even changing the funding scheme. Sure. And this would be really a change on that level. But I have not gone into this because I was really only speaking about storing and making available objects from a very librarian perspective, yes. But I still think in the next few years, still we will have a lot of competition. And what I like actually is the model of how GitHub works. And this gives us a peek into what will maybe happen in science as well, yes. Linus Torvalds, who's actually the inventor of Git, called GitHub, what was that name again? World of Warcraft for Programmers. This is actually funny, and he nails it, yes, because it's okay, I'm all bragging about my contribution to different projects, and this is all what this GitHub is about, but this is actually not that bad. It's maybe a little bit better than what we have now with science, because you can really track and very granular actual contributions. Yes.
Just the point about you saying let's like open the peer review to not being curated by editors.
Yeah.
But usually the problem with reviewing papers is that nobody wants to review them.
Yeah, absolutely.
And you know, all people, all researchers will say, well, you know, I don't want to review them unless I'm actually asked very nicely, and that's kind of usually the job of the editor to do that.
Absolutely,
So
absolutely.
who is going to be doing that job?
We have many places in academia, and especially in the workflow, in the flow of research objects, where we will have to fix the incentive structure. Right now, this works like you are being nicely asked. You know that there's in the background this large publisher brand, and you like to brag about, okay, I do peer review for Nature and Science and so on.
Exactly.
And these are crucial things right now, so we will have to come up with something different. But on the positive side of things, I think that there's already some kind of, or at least, an aspect of that motivation is that researchers feel indebted to the scholarly community. And that is another reason why they do a peer review. This is not all that bad. I mean, you have people reviewing papers for journals that are absolutely not that popular and so on. So we will have to come up with something new. We will have to reinvent it. But then again, we don't start with zero from scratch. I don't know.
Just as a thought, if you imagine you share your data openly on IPFS, it's there, your analysis, your result, and you faked it, what it's going to do to you. So you, like, I mean, so the peer review may solve itself based on the fact that you're claiming something, and if others then say, oh, but this guy is always wrong, then
So you want no reputation system? I thought we just said no reputation system.
No reputation system.
Let's get rid of it.
You will need a reputation system, but somebody needs to point out that your data is actually a fake, yes? But this should be about the data and not the person. So maybe you
Yeah, but in the end, the reputation system is about you publish your data and it's fake 10 times, but then on the 11th time you publish the data and it's amazing. But everyone's saying, oh, it's fake. The personal reputation system, that's the whole point of the reputation system. So if you bring it back, then there was no point taking it away in the first place.
Yeah, so just regarding the reputation system, so I want to make a statement, so if you measure a system, right, and people know how it's being measured, you change the system, right? And blockchain allows us to invent new measurements to reputation and maybe to distribute research money according to some factors that are not foreseeable and very quickly. So let's say one year this funding agency could distribute the money regarding this smart contract, maybe how much open data was shared, how many on Twitter, so how many good comments, and the next year on the other one. So it becomes completely unpredictable. And this could be a new way to prevent the adaptation to the system. So people, today people do things that it's necessary to publish in a higher journal to get a high impact factor. They don't do what's good for science, right? And this is so it's completely deviated from it, right? And on ResearchGate, as you said, people share on the platform, and it might be in some alignment with science and sharing, but it's tweaked towards the interest of ResearchGate, right? To help the people on the platform. And if we have blockchain reputation system or assessment system, they can easily be changed, right? The problem with Google PageRank is if it's leaked out to the public so that people know how to change their web page to have a high rank. Yeah? That's why they keep it very secret. And that's very important. And I think blockchain allows here, with all the attributions that you mentioned and everything, to come up with new systems quickly and easily and transparent.
That's the beauty of it, yes. We have a completely new development model for the infrastructure, yes. When we would have this single source of truth, this dump that everybody can work on because it's in a way reliable. Yes, you can more easily come up with new lenses, yes, and better lenses.
Yeah. I mean, Lambert, maybe this GitHub idea that you mentioned, I think it's a very nice one to use in the reputation fits because, like, I'm a biologist, so my reputation will be on my CV or that I have a lot of first authorships, yeah. But there's a lot of poor IT guys that I rely on, and they are like in the middle, basically, of my papers, and they hardly make it to the front, basically, because it's.
But they usually pay more than you do.
Oh yes, that's true. But if they want to have an academic career, I know from some colleagues actually what they are doing is that they're using their GitHub accounts and they're pasting that in their CV already, right?
Yeah.
So basically the reputation of the person is being built by the contributions, yeah. And that's something that's actually lacking in my field at the moment, but it's already there for people that are using platforms like this. And I guess we need something like that, right, to make sure that the people can move around and find jobs. But I think that the current way is not entirely fair or evenly distributed.
But very good, valid question. Sure.
Was it my question?
Yeah.
Wasn't your question.
What was
Sorry, what you said before.